Hi, everybody. This time we're going to talk about a variety of different types of liquid solutions, and they're based on the size of the particle that gets dissolved. Now, the different kinds of solutions are called just plain solutions, suspensions, and colloids. So let's take a look at each one of these. If we refer to the plain old ordinary solution that when we use the term solution, most people think about, in chemistry, there's a specific definition. To have a stable solution, we're talking about something that doesn't change through time. No solids fall to the bottom, no precipitate falls out. You can pass this entire solution through some sort of a piece of filter paper. Filter paper is very much like a coffee filter, and the solution will not be changed. Actually, there's a scientific definition. The particles that are dissolved inside of this solution have to be 1 nanometer in diameter or smaller. So very, very small little bits and pieces. The solution needs to be transparent, meaning not cloudy. It can be color. Color is okay. And the solute, the thing that is being dissolved, can be atoms, it can be ions, or it can be molecules. So I have pictured for you a whole collection of true liquid solutions. A good cup of coffee without cream, a nice Kool-Aid solution without the ice, but I like the Kool-Aid smile there. Plain soda pop, whether it's Coca-Cola or Orange Crush or grape soda, whatever that is, saline solution, a glucose solution that you might give a patient, a nice glass of beer, but not cloudy beer, cranberry juice, apple juice, something that is a clear juice. All of those are true chemistry solutions. Now, the next type of liquid solution is called a suspension. A suspension is a heterogeneous mixture. If you remember long ago, heterogeneous mixture means that every sample could be different. These suspensions are things that contain larger particles, and these larger particles are things that can fall to the bottom. The classic, of course, is vinegar and oil salad dressing. You have to shake it vigorously before using. So many salad dressings, here's a picture of a noodle soup, and you have to stir it well in order to get one spoonful to be similar to the next spoonful, but they don't have to be the same. Nail polish, if you've got a nail polish that's got glitter or something in it, that's going to be a suspension. You have to shake it well to get glitter in every application. A muddy stream. There are particles of solid clay, solid silt, solid sand that are suspended in that water, but given time, they will fall to the bottom. If you use a spray can, it's going to say on the bottle, shake well before using. And that's because the product, the paint, is going to be at the bottom. The aerosol, the propellant, is going to be on the top. And you have to mix them well in order to get both at the same time. So if any time you pick up a product and it says shake well before using, odds are it's going to be a suspension. In between solution and suspension, there's an intermediary size particle, and they make colloids. Sometimes they're referred to as colloidal suspensions. But a colloid has a particles that's larger than a solution, but smaller than those in a suspension. Now, these are suspended particles that do not settle out over time. They have a tendency to appear milky or opaque. A lot of dairy products make colloids. Whipped cream, ice cream, milk itself, butter are colloids. Fog is a colloid. Smoke is a colloid. And these are little tiny particles of fat, very often in dairy products, or little particles of water droplets in fog, or little smoke particulates, little hydrocarbons in smoke. Colloids also have a unique property called the Tyndall effect. The Tyndall effect means that they scatter light in all directions if the solution is not too thick. You're not going to see this, of course, in ice cream, but the Tyndall effect can be seen in smoke or in fog. The Tyndall effect is the reason why you are told when you're in a fog, do not turn your headlights on bright. It is never a good idea to turn your headlights up on bright when you're driving in fog. And the reason is because of this. Normally, when you turn your headlights on, your headlights are going to go straight ahead so that you can see. When you turn your headlights on to bright, what happens is it gives you a wider path. And it's great if you're on country roads and there's nobody around and you get a wider field of view. The problem is if you do this on a foggy day and the Tyndall effect is in effect, all of the water droplets in the air are going to just glow. This is a beautiful image of the Tyndall effect. Flashlight passed through clear water, and then a flashlight passed through water with a little bit of milk added. And you can see the entire glass glows. Well, if you put your headlights on bright and in the fog, all of the surrounding in front of you is going to glow. And what it's going to do is it's going to reflect that light back to you, and it's going to really decrease your visibility instead of increase visibility. And that's why you are not supposed to turn your headlights on bright when you're driving in the fog. So we've talked about solutions, suspensions, and colloids. So this chart does a lovely job of summarizing this. Solutions, homogeneous mixtures, small particle size, atoms, ions, molecules. They don't separate upon standing. They cannot be separated by filtration, and they do not scatter light. Colloids, an intermediate size, heterogeneous mixture. They don't have to be the same sample. One sample doesn't have to be the same as the next. Intermediate particle size. They do not separate upon standing, and they cannot be separated by filtration. They do scatter light. Suspensions, again, heterogeneous. One sample does not have to be the same as the next. Large particle size. The particles do fall out given time. They can be separated by filtration, meaning a filter paper or something like that. And they may scatter light, or they may be opaque. They're so thick and goopy, no light's going to penetrate through them. So these are our three types of liquid solutions that you might encounter.